Do you know what is the topic of the decade as far as your IT career is concerned? It is a data science. So in this video, I'm going to talk about data science as a career and what all necessary skills required to master your journey as a data scientist. So let's deep dive into data science as a career path and its skills. So as far as your data science career is concerned, you need to know some basic things. Then maths plays very important role. Apart from that, feature engineering, there are various ML algorithms, so you need to know that. Then apart from that, there are some data mining algorithm, AI, ML implementation, so various programming language, various libraries are there, so which programming language use which kind of library, that we will see. Then generative AI, it is a topic of the current scenario as far as machine learning and data science is concerned. Then deep learning use cases we will talk about. Then Google AI ML and how we can determine exact which module of the Google AI ML we need to choose. Then something I'll talk about AI ML ops also, and product based ML tools, chatbot, the latest greatest thing as far as data science and auto responses are concerned. Then online community platform and their subscription. And apart from that, we will, I'll talk more about cloud ML as a separate topic in a cloud computing. So let's talk about data science as a base. So as a data science base is concerned, you need to know at least one programming language. So right now, if you go in the market and if you see the lots of noise around Python, and that's where you need to learn Python. And these are some of the editors related with Python. So out of that, PyCharm is quite popular. Then it is R programming language, and you can use R Studio for R programming language. Apart from that, if you are from big data world, that's where Scala is grabbing lots of attention. But there is a Go language and Java. Also, we have lots of use cases as part of the AIML journey, and that's you can develop. There are various editors when it comes to the Java, but out of that, Eclipse is very famous. Then C Sharp if you are from Microsoft tools and technology stack, and that's where Visual Studio Editor plays very important role. And we have another popular programming language, that is MATLAB programming language as far as your data science engineering career is concerned. Then let's see what all the popular libraries and their contributors are there. So let's see what all those popular libraries as far as three most popular languages are concerned as part of your data science journey. So let's talk about Python first. So when it comes to the Python, we have a TensorFlow, Scikit-learn, PyTorch, and Keras. These are the most popular libraries. And when it comes to the Scala, we have a Deep Learning 4J, Spark ML, and Prediction IO. These are the topmost popular libraries. And when it comes to the R, we have a H2O, MLR, and XGBoot. These are the popular libraries. So that is about popular libraries and the most popular programming language. But when you are starting your career as a data scientist, no doubt you need to know something about RDBMS and SQL programming language. So without that, it's very difficult to survive as a data scientist in your career. So that's where you need to know at least one database. And as far as SQL is concerned, you need to know basics of the SQL, how the table is created, how to give access to the table, and how to play with that data. And that's where joins comes into the picture. There are various types of joins, so go and deep dive into those joins: trigger, function, views, indexes, query optimization technology, common table expression. So these are some of the things associated with SQL, and you need to know in order to master your data science journey. Apart from that, there is data modeling. So once you get high level requirements as far as your data understanding is concerned, you need to document and model them. So that's where data modeling, ER diagram, proper domain and its requirement understanding, that plays very important role when it comes to the high level designing of RDBMS tables. Apart from that, we have a cloud databases, but again in cloud databases we use the same SQL query language as far as playing with the data. So that is all about RDBMS as a data science journey. Then before giving data to data science algorithm or ML algorithm, we need to massage that data, and that's where ETL tools and technology plays very important role. So there are various ETL tools like Informatica, SSIS, Data Stage, Oracle, Data Integrator, Talend, Pentaho, and there are many more. So you need to know that. Apart from that, cloud ETL tools are there. So I'll cover it as a separate topic as part of the cloud technology, and you need to know some basic concept related with data warehouse and its designing. And there is another important component as part of the data science journey, that is visual representation of your data. And that's where you need to know at least one reporting tool that, and these are some of the popular reporting tools like Power BI, Tableau, ClickView, Grafana, Excel. Excel is very important as part of your data science journey. And there are various types of charts and graphs. So you need to know most of the charts and graph in order to make your data in a more readable and graphical format. So that is about reporting tools. But apart from that, you need to know graph reading and data storytelling skills also. You need to be subject matter expert of specific domain. And as a data analyst, you need to know feature engineering, data wrangling, and exploratory data analysis. These skills are also very important. So that is all about to give some base as a part of data science journey. So as part of data science journey, you need to know mathematics and statistics, and that's where probability, differential calculus, algebra. In algebra, again, bias and variance, coefficient, confusion matrix, normal distribution, correlation, variance, point estimate and confidence intervals, regression analysis. In regression analysis, again, we have a linear regression, polynomial regression, Bayesian regression, ridge regression, lasso regression, logistic regression, linear programming. So these mathematical skills and statistics skills at the basic level, at least you need to know. Apart from that, when you go for a data science journey, the most important part will be your feature engineering. And in feature engineering, again, you need to select right feature in order to give data to your ML model, and there will be some functional flow. And as part of your data science journey, you need to know feature engineering, because in order to develop data model, you need to extract right features, and that's where all these techniques comes into the picture. So out of that, there is a subset selection, information theory, then independent criteria, lasso based FI FS selection theory, feature selection theory, then structure learning, correlation FS, feature selection, regularized trees, meta heuristic methods are there, and then some embedded in machine learning algorithms. So these are some of the techniques which are you need to master to identify right features as part of your feature engineering. So that is about feature engineering. Now coming to the most crucial part of data science journey, that is machine learning algorithm. So when it comes to the machine learning algorithm, we have a supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, neural network for deep learnings, and some ensemble learnings are there. So let's see what is there as part of the supervised learning. So in supervised learning, you need some human intervention, right? So that is where supervised learning comes into the picture. And we have classification algorithm, regression algorithm, and again anomaly detection algorithm, collaborative filtering. So in classification algorithm, again, there are two types, like binary classification and multi classification. So in binary classification, we have logistic regression, decision trees, random forest, linear support, vector machine, SVM. These are the algorithm. And when it comes to the multi class classification, we have logistic regression, again ordinary, least square, decision tree, random forest, naive bayes classification, k-mean algorithm. So in k-mean we have knn, that is nearest neighbor algorithm. And when it comes to the regression algorithms, we have linear regression, logistic regression, ridge regression, lasso regression, polynomial regression, decision tree, random forest, Bayesian regression, ordinary least square regression, neural network regression. So these are the regression algorithm. So again, there is anomaly detection and collaborative filtering. These techniques are also used as part of supervised learning. In supervised learning, we have to evaluate the performance of model in regression analysis. And for that evaluation, we have various techniques like mean absolute error, mean square error, root mean square error, mean absolute percentage error, root mean square algorithmic error, coefficient of determine R. So R square with adjust to feature quantity. So these are some of the technique which we use for evaluation of the model. So once you build up the model using supervised learning as part of the regression analysis, these are the technique used for evaluating your model. And there are many use cases, but one example I have given as part of the supervised learning, we use supervised learning algorithms for fraud detection. So that is all about supervised learning. Let's see what is there in unsupervised learning. So let's see what are the techniques used for identifying unsupervised learning. So we have clustering, dimension reduction, independent component analysis, association rule learning, collaborative filtering, pattern search. In clustering, again, we have k-mean algorithm. In k-mean, we have centroid-based algorithm, connectivity-based algorithms, density-based algorithms, and probabilistic. Then mean shift is another clustering technique is used as part of unsupervised learning. Then fuzzy C-mean, DB scan, agglomerative clustering techniques is used as part of the unsupervised learning. In dimension reduction, let's see what all the algorithms and techniques are available. So we have TSNE, that is T distributed stochastic neighbor embedding, then PCA principal component analysis, singular value decomposition, LSA, and latent semantic analysis, linear discriminant analysis, and LLE, that is loyal linear embedding. So out of that, LSA is used for natural language processing, and LDA is used for dimension reduction technique. So that is about dimension reduction. But apart from that, we have independent component analysis, association rules, learning, collaborative filtering, and some search pattern we use. So out of that, we have a priori, then EC lat, and FP growth, that is frequent pattern growth algorithm to identify the pattern search. So in case of unsupervised learning, there are plenty of use cases, but couple of them I have listed here. One is social network application. We use lots of unsupervised learning. And then language prediction. It is one of the popular use case where supervised learning is being used. So that is all about unsupervised learning. Now let's see what is there as part of reinforcement learning. In reinforcement learning, we have a model-free reinforcement learning and model-based reinforcement learning. So let's see what is there as part of model-free RL. So policy optimization is the technique used. And in policy optimization, again, we have a policy gradient, DDPG, A2C, A3C, DT3, and PRO, SAC, and TRPO. These are the policy optimization technique being used. And yeah, another part is there as part of model-free reinforcement learning, that is Q learning. That's where DON, depot network, DTPG, TD3, SAC, CP, C51, and QR, DQN, and HER. These are the Q learning techniques used as part of reinforcement learning. In model-based RL, we have again learn the model, that is world model, I2A, MBMF, and MBV techniques, and alpha 0 is part of the given the model. So again, just you need to explore all these keywords as part of your reinforcement learning. So that is about reinforcement learning. Coming to the neural network, that is means in machine learning algorithm, neural networks are very important. And when it comes to the neural network, we have various types of neural networks that we can see here. So we have perceptron, feed forward. So again, it's a neural network, the way we have a brain, right? Brain will have lots of neuron, and through that they will communicate with each other, right? So similar pattern as part of this algorithm they try to implement, and these are some of the charts and components related with neural network. Apart from that, let's see what is there as part of neural network. We have CNN, means convolution neural network, GAN, generative adversarial neural network or network, RNN, MLP, multilayer perception, radial basis function network, and auto encoder and transformer. These are some of the neural network and deep learning algorithms available as part of data science. Apart from that, we have Ansible Learning. So what is Ansible Learning? Where multiple models are bring together. So if you see here, combine multiple weak models and learners into a predictive model to reduce bias, variance, and improve accuracy. So when you develop your model, there are chances that it will be a bias with certain output, right? A certain we need to provide proper intelligence, and that's where we combine different technique and we try to make it more accurate output. So that's where bagging, that is part of the random forest, boosting, which is ADA boost, CAT boost, XG boost, light GBM, and gradient boost, and stacking. These are the technique used. So that was all about machine learning. Let's see what is there as part of data mining algorithms. So in data mining algorithms means you need to play with that data, right? You need to mine that data. So that's where we have crunchers, guides, advisor, predictors, uh, tacticians, strategists, lifter, partners, OKs, and supervisors. These are the data mining algorithm and techniques used. Now moving on to the AI/ML implementation. So as part of AI/ML implementation, there are various techniques. So first you need to identify the data. And as part of the identification of the data, you may need to use some test data or training data. Then you will build the model, and you will keep on feeding the data. You will train that model. You will see the test phase practices to check the right output of that model. Now coming to the next part, which is very important. So as part of the Python development, Scala development, Java, and R programming, already we have seen the popular libraries in this programming language, but let's see a few more libraries as part of Python implementation. So we have uh, so if you are using Python, then you need to know NumPy, Pandas, Matplotlib, then SciPy, Seaborn. These are the libraries, and you can see these are the libraries which are used for visualization out of that Matplotlib and Seaborn. Then scikit-learn is very popular library as far as machine learnings are concerned. Then stat model for statistic, and for web crawling you have to use Scrappy, URL-lib, then Beautiful Soap, Request HTML. So these are the libraries. But apart from that, we have a Request, LXML. So these are the libraries for web scrolling kind of output if you want to. Now coming to the next part, something which is related with text data or natural language processing. So if you want to do natural language processing, we have very popular library, which is NLTK, Natural Language Toolkit. Then SPA-Sci, that is the library which is used for NLP using Python for speed. So another Python is another compiler in case of Python. Apart from that, we have a Fuzzy Wuzzy library, then Spicy, Regex. Again, it is very important as part of text data analysis, Text Blob, and Core NLP. So these are the library used for text analysis and NLP. Suppose you want to do some image processing. So that's where OpenCV, Pillow, Scikit Image, Simple CV, Mahotas, these are the libraries available in case of Python. So while doing these things, you extract the metadata and the text from over the thousands of different file types. For example, PPT, XLX means Excel files and PDF, and you do that data analysis. So as part of the deep learning, we have Theano, Blocks, TensorFlow, Keras, MaxNet, PyTorch, XGBoost, and LightGBM. These are the libraries popular. And when it comes to the big data, we have a PySpark, right? And in PySpark, we have MLlib, and that is from Databricks. So these are the libraries. Now moving to the next part, which is Scala. So you need to know the Scala's basic. Again, as far as big data is concerned, so you need to know PySpark. So in PySpark, you need to understand the basics of the PySpark, MLlib, MLflow, graphics. These are some of the libraries you need to know when it comes to the understanding data science using Scala and Spark. Now moving on to the Java. In Java, we have Mahout as a big data library, but apart from that, we have a Tika for playing with different types of file format and extracting data from those files. And Tika is developed by IBM. Okay, so Tika is very popular and open source library available while playing with various file format. When it comes to the R programming, we saw already, right? We have H2O library, which is very popular. But apart from that, we have ggplot2, that is for visualization. Now moving on to the most crucial part, that is ML algorithm selection. So when it comes to the ML algorithm selection, we have very good flow chart. So suppose your use case is related with dimension reduction, right? So that time you will go for unsupervised learning using dimension reduction. And again, you can select that specific algorithm based on this inputs. And suppose if it is not dimension reduction, then you will check whether it has some responses in terms of data. Then you will go for unsupervised learning using clustering technology, and you will select that particular algorithm from these data points. And suppose again you got some responses, means you have some input there, and you will check the predicting numerics, right? What kind of numeric predictions you want to do, and based on that you will go for unsupervised learning algorithm using regression technologies. And if it is not associated with unsupervised learning, then you will go for supervised learning using classification technology, and based on those inputs, again you will select that specific algorithm as part of your data science model generation. Now coming to the next topic, which is very hot topic right now, that is generative AI. So lots of noises around generative AI. So when it comes to the generative AI, it is all about text to image, image to video, video to audio. So all these three forms of the data, image, text, audio, comes into the picture. So text to image conversion, if you want to do, then we have these popular providers in the market. Suppose text to video you want to do, then we have these are the providers right now in the market. Then text to audio, so again we have these are the entities available in the market right now as part of the text to audio generation. If you go text to text, suppose you feed some data and you want to generate some output as part of natural language processing, then these are the provider right now in the market. Apart from that, if text to motion, text to code, suppose you want to generate the code from text input about for your query, so these are the tools available. Then text to NFT, then Lens AI is the technology which is very popular. Then text to 3D kind of animation you want to do, then that's where Dream Fusion and these Get 3D and Clip Mesh comes into the picture. Then audio to text, we have Whisper and Assembly AI providers are there. Then audio to audio, we have Audio ML and Voice OD. These are the provider. Then brain to text, I don't know what this exactly, from speech from brain, some advanced generative AI things I can see here. Then image to text, we have these provided. So out of that, GPT-3 X image caption, that is from OpenAI, which is very popular. So again, I got this particular presentation from LinkedIn, and I thought I should make it as part of this presentation. So that is generative AI. Now moving on to the next part, which is deep learning use cases. So again, there are lots of deep learning use cases. So mainly something which is related with neural network. So you can see here as part of RNN, these are the techniques available. CNN, we have these techniques. Autoencoder and GAN, we have these respective use cases there. And there are many more actually. Okay, I'll not go and elaborate each and every use case because every topic is again separate learning. So that is about deep learning. Now coming to the Google ML, AI ML. So suppose you are working on the Google ML, and if you want to select specific path, I mean, what kind of algorithm and what kind of output you require, then this is the algorithm you can use. So does your use case fit pre-packaged AI solution? If yes, then these are the solution available from Google AI ML. If no, then do you have your own training data? If answer is yes, then you will move for the next thing, or otherwise if there is no, then you go for pre-trained APIs, and these are the options available as part of the Google AI ML. And suppose you don't have, if suppose you have your pre-trained data, then data in BigQuery, and users are more comfortable with SQL. If users are more comfortable with SQL, then you can go for the BigQuery ML. And if no, then again you have to check writing model in training code yourself, then you can go for these options. And if no, then there are these options. So that is something which is related with Google AI ML. Now another thing which is very popular right now in the market, which is ML ops. Okay, so ML ops means whatever model you generate as part of the data, we need to keep on maintaining their versions, right? So first, what we have, you have some data source, some data pipeline, and from there you identify the feature, you store and you transform that data, and you make it in a usable format. Then you create your model, right? You give training to your model. Then there will be continuous evaluation of that model, and from there you will deploy one specific model as part of your production use case. Then that model will do some real-time prediction as part of API expose, and model monitoring will happen in your case, and then you will get to see actual result as part of that model. So this entire thing is maintained for means ML ops is for maintaining various versions of the model and deploying right version in order to do the prediction dashboard. So that is all about ML ops. Now moving to the next topic, which is product-based ML tools. So again, there are various products as far as ML analysis is concerned. So out of that, I've worked extensively in Cloudera toolkit. So that's where we have CDSW, that is Cloudera Data Science Workbench. And recently they come up with modified version, that is CML, Cloudera Machine Learning. But again, we have a SAS, and SAS has statistical compute ML. Then we have Alteryx, then Databricks, SageMaker, Data IQ, Data Robot, Veka, H2O AI. So that is from our background. OpenAI is there, right? ChatGPT, which is very popular tool from OpenAI. Then Prediction IO, that is again from open source community, that is Apache, RapidMiner, Orange, Data RPM. These are some of the product-based ML tools if you want to explore your data using readily available tools. Then coming to the chatbot. Again, various chatbots are there, but out of that, these are the popular tools and technologies available as far as chatbot is concerned. But we have a Watson, which is very popular IBM chatbot. Then Google is planning to come up with its own chatbot, that is Bard. Already it is there, I think. And then we have a ChatGPT where we can fire a query, and lots of things are being said about ChatGPT right now. So that is all about chatbot. Now coming to the community. So suppose you want to build up your career as a data scientist, you need to subscribe to right communities. So there are many communities as far as data science is concerned, but I am explicitly talking about Kaggle here, so which is very popular community. You can learn lots of things in this community. There are competition and lots of free data sources are also available if you want to play with various machine learning algorithm. And the last topic is about cloud ML. So I'm going to cover it as a separate topic as part of cloud ML when I'll talk about cloud computing technologies. So these are the things associated with your career as a data science. So what I feel, you need to select that one programming language, one database, and out of this three types of data set, I mean text, image, audio, video, I mean 4 data set. First go with the text data set, and then you can drill down to the specific stream of the data science, like natural language processing, or suppose you want to go specifically with image processing career as a data science, or audio or video. So select that stream and explore those specific libraries as part of your data science. So please comment which programming language you want to use as part of your data science journey, which database you want to explore. And the third, out of the text, image, audio, video, data processing, so which type of data is your targeted data you want to learn as part of your data scientist journey. So all the best, get to know about all these keywords and have that deep understanding once you explore it in a more detail. So that's all about being part of your journey as a data science. Thank you for listening.